So what is recursion? The idea is that recursion is a self-similar process where you apply the same operation at either bigger or smaller scale. And you have some examples here that are pretty famous recursion examples. The one that I always find the most interesting is Sierpinski's triangle or Sierpinski's gasket. And it kind of starts as a big black triangle, and then you cut out a white circle inside of it. And then for the three black triangles that are left over, then you cut out white triangles from inside that. Then for the nine triangles that are left over that are black, you cut out white triangles from inside of there. You just you continue that process indefinitely. And so there's lots of examples of recursion that you can see. For those of you who studied the Mandelbrot set before in math or not, it's a really cool thing called a fractal, which most of these are called. Um, so recursion is just the idea of self-similarity, that if you zoom in on a picture, you will see more examples of the original picture. And you see that really clearly in Sierpinski's triangle. If you were to zoom in on just like the top part of this iteration of the triangle, what you will see is, as some of you know, the Triforce from Legend of Zelda. So uh, in terms of programming, where we see recursion is in sort of the way we define certain functions. So let's start with something that I think you might know from your math class called piecewise functions. If not, it's not going to be too bad to introduce it right now. The idea is that the evaluation of the function depends on what our x input is. So if our input is 0, it asks first, is it true that 0 is bigger than 1? It's not, so we do what it says in the otherwise condition, which is we just say the value is 3. For f of 1, once again, 1 is not bigger than 1, so we do the otherwise condition, which is 3. When we put in 2, 2 is bigger than 1, so we do this condition. So 2 minus 1 is 1, times 2 is 2. And when the input is 3, 3 is bigger than 1, so that's 2. And sorry, I said something really weird there. 3 is bigger than 1, 3 minus 1 is 2, 2 times 2 is 4. So that's what's called a piecewise function that many of you probably have learned in math before. Now, what's different is these types of functions. And what's different, what you should see here, is that the function is named g, and the word g shows up once again inside the definition of the function. So it is a self-referential function. The value of the g function is dependent on the g function itself, which is kind of mind-blowing. So let's kind of go through some examples and see what happens. It says that we're going to do g of 0. So if our input is 0, it's not bigger than 1, so we do the otherwise, which is 3. For g of 1, 1 is not bigger than 1, so we do the otherwise, which is 3. Where interesting things start to happen is when we do g of 2, because 2 is bigger than 1, so we're going to do 2 times g of 2 minus 1, or 1. Now, here's where it's helpful that we did this kind of initial stuff. We know what g of 1 is, it's 3. So this is really just 2 times 3, which is 6. Likewise, when we do g of 3, 3 is bigger than 1, so we're going to do 2 times g of, well, 3 minus 1 is 2. And we know what g of 2 is, it's 6. And so the way that we evaluate a function like g of 3 now is going to depend on the definition of what g of 2 is, which is dependent on what g of 1 is. And the hope is that at some point we will get down to something that's called the base case. When we are not in the base case, we're going to be in what's called the recursive case. So when we are calling the function again, we're going to call that a recursive case. The otherwise condition is called the base case, or the case where we have the immediate answer. G of x is called a recursive function because it refers to itself. And a funny joke that I like to tell every year is the dictionary definition of recursion is see recursion. I don't know if anybody's laughing right now, but I always think that's funny. So like the definition of what recursion is depends on the definition of recursion. See, it's funny. If you want to see another level of this, Google recursion and see what Google says, which I always find very enjoyable. So in methods, what you'll see are the following. So for a function f of x, this is just a standard function that takes inputs and gives you return values. So this is not recursive, not recursive. Whereas g is recursive, oops, and that's because the name of the function is g, and you can see that there's a call to the function itself. So that's a basic introduction to what recursion is.